So last class, we had a whole discussion about boxes, right? My past job with software boxes and we looked at what happens if you take a box and open it up so you could print it. So for example, if this were the box and I were to open it up so that I could print it on one side, and maybe that is my base right there. This is called a net, or an explosion, so to speak, of a three-dimensional figure into its two-dimensional components. And what we'd see is that I could have one wall over here, and I could have one wall over here, and I could have one wall over here, and I could have one wall over here. And then I'd also have to somehow make the top come off one of these wings. Doesn't matter which one, there's actually several choices. But can we agree that this is generally what we'd be looking at if we took this box and exploded it into two-dimensional components? So if we wanted to, we could find the surface area of a prism by breaking it into these components. And what we talked about last class is that that's not a very efficient way to do it. Instead, what we could do is recognize that length times width gives me an area. So that would give me this area. And then if I did that again for this side, and et cetera, followed it all the way around, what I'd end up with is that the perimeter times that height would give me the lateral area. Lateral area is the perimeter times the height. And then if I wanted to get the surface area to include all of them, I would just add on my two bases, and that would yield my surface area. Any questions on that? Quick review of last class. And again, that applied to both prisms as well as cylinders. What was the distinction? How were these two things done differently? How do you find the base of a square? The area of a square? Length times width, good. And how would you find the area of a circle? Pi r squared. So that's what's different. How you find the areas of those bases and how you find the perimeters. But the process in terms of lateral area, surface area is the same. So today we're going to extrapolate that, take it one step further by saying, what if instead of having a prism, we had a pyramid? Well, conceptually, actually, I'm going to redo that. Let's do that with a square-shaped base, because then it gives better contrast to the sides, which are triangles, the faces, which are triangles. Okay, so there's a pyramid. And if I want to find the surface area, one concept would be I could break it out into a net. Again, saying, all right, so here's my base on a flat piece of cardboard. And what would have to come off of each of those sides? Would it be rectangles again? Triangles, right? We'd have triangles coming off of each of these edges. And can we agree that this would fold up to make this shape? So if I want to find the lateral area, that means the surface area, but not the bases. So I'd be looking for these four things. And what shapes are those? They're triangles. How would you find the area of a triangle? What's the formula for the area of a triangle? Yeah, or 1/2 base times height, right? So if I wanted to find this, I could use the side of the base as the little base of this triangle, but I'd need an altitude. So in order to make this work, what I need to have is the line running down the side there, like dripping down the face of this thing. Reminds me of the old joke. First you say is if a rooster's on top of a barn and it lays an egg, which side does it roll down? Anyone? Let me say it again. If a rooster lays an egg on top of the barn, what side does it roll down? Roosters don't lay eggs. Okay, sorry. So if a hen lays an egg on top of it, it's a two-part question. The hen lays an egg on top of a barn, what side does it roll down? The outside. Wah, wah. Okay. Thanks. I'll be here all week. Fortunately, it's Friday. All right. So what we're looking at here is we've got this pyramid shape. And just like we did before, we're going to say that the lateral area plus the bases will make the surface area. But this time, how many bases will we use? Just one. And for the lateral area, if we wanted to add up all four of these triangles, we'd have to do the 1/2 base times height, and we got to use this new height. So the lateral area formula is 1/2 PL. Let's get into this. So to do these, 2 steps. First, identify what the pieces are that we're trying to solve. The measurements we need, that comes from these. L, P, and B. So I'm going to say that L equals, P equals, and B equals. L stands for slant height. So what's my slant height in this picture? You can look over here to see what they're pointing to. This is where that egg rolling down the side of the barn came from. 11.7 is my L. What's my P? Good. There's 8 meters for each side. There's 4 sides, so 8 times 4 is 32. What's my B? Good. It's a rectangle, so side times side, 8 times 8 equals 64. Once you get those parts, all you got to do is plug them into these LA and SA formulas. I am going to make one little adjustment to that. Let's say use the LA just as it is, 1/2 L times P, which in this case would be 1/2 what times what? $11.7 times 32, which means 0.5 times 11.7 times 32 is 187.2. So that's our LA. And then the adjustment I want to make is that our SA, they put it over here in the formulaic value, but I want you to think about it as it's the lateral area plus a base. So write it as SA equals lateral area plus base. We just found the lateral area. We don't need to do that again. So 187.2 plus the base of 64 gives us 251.2. These were meters, so that's meters squared. Any questions on that? Okay, would you please take a moment to try number 2 and 3 yourselves? Go. So number 3 has an issue without showing its slant height, but if you draw it in, you can see that you can form a nice little right triangle there. How long is this side on the bottom? Good. It's half of this length of 18 because it goes from the center point out to the edge, or half the distance. So now we've got a little right triangle, 3, 8, L, the unknown side. And we can do a quick Pythagorean theorem. 3 squared plus 8 squared equals L squared. 73 equals L squared, so L is square root of 73. And that's how we'll fill these in. See if we can finish this one up, please. All right, what's going to make 4 and 5 different? The bases are triangles. So when you do your B, instead of doing side times side, you're going to have to do 1/2 of two things multiplied together. And what has to be the relationship between those two things? Whether you call them base and height or length and width or whatever. What has to be the relationship between base and height to multiply them together as area of a triangle? Good. They have to be perpendicular. So we can see that 10 is going to be our base. But to get our height, we have to choose this one they've drawn across the center of the base. 8.7. Otherwise, it's exactly the same. Well, and I guess the perimeter is, instead of 4 sides, the perimeter is going to be 3 times 10, which is 3 sides, 30. Okay, any questions on finding the lateral area and surface area of pyramids? Okay, I'll leave those for you guys to finish up. And let's flip to the back page, the second page, excuse me. Now, the second page is about cones. And are cones similar to pyramids? Not in a geometric way of similar, but just kind of sort of the same? They are. And in fact, we can use the exact same setup. We can say L equals, we can say P equals, we can say B equals, we can say that the lateral area equals 1/2 P times L, just like we did before. And we can say that the surface area is that lateral area plus base. Everything looks exactly the same as you just did so far. If I want to find L, what am I going to pick? Good, 11.4 is our slanted height. Now, here's where it gets a little different. When we wanted to find the P of a square, we took one side length and multiplied it times 4. When we wanted to find the P of a triangle, we had to take the side length times 3. Now we're finding the P of a circle. How do you find the P of a circle? I'm going to suggest we write this in here. Underneath this stuff, let's write P is equal to, we don't usually call it a perimeter. What do we call it in a circle? Circumference. So 2 pi r. And then B is the area of the base. How do you find the area of a circle? Good, pi r squared. And again, what we're saying is that we can use these same formulas. Lateral area is 1/2 P times L, and surface area equals LA plus B, single B. These are exactly the same formulas as the other side. The only difference is when you find the perimeter and the base, you have to choose the part that's appropriate for that shape. You'll notice that they've also introduced some different formulas. Pi RL. Well, that's what happens when you do 1/2 P times L, and P is 2 pi R. Half of 2 pi R is pi RL. And then here they took that same pi RL and they added one base, pi R squared. Historically, when I teach this, I tend to get students to remember that pyramids and cones are the same formula, just like prisms and cylinders are the same formula. And all you're caring about is what shape the base is, the two-dimensional figures. I do that normally so that it reduces the number of formulas you guys have to memorize. Because in normal days, you guys would have to memorize these formulas. In this post-COVID apocalyptic, whatever we're living, I'm allowing you guys to use your notes on tests. So you could use these formulas. If you want to, you can. I encourage you to think about them this way, though, because that's consistent and might drive into your long-term memory better. I will say that some of these might be easier for the backward solving ones where you're actually backing into finding the slant height, or you're looking to find the radius or something like that. Okay, the rest of this sheet is those types of, well, here, maybe I'll do one more with you. Let's do number 11. How do we do number 11? It's asking for the surface area of this shape. What does surface area really mean? Everything on the outside, right? Like if you dip this in paint, what would come out painted? So this shape is not a traditional figure. Instead, it's an amalgamation of different shapes. So do you see that it's got this component? What would we call that? Definitely not a cylinder. It's one of these. A cone, okay. What part of the cone is it? Is it the surface area of the cone? Not fully. It's the LA. It's the lateral area of the cone. So let's write that. Lateral area of a cone. We also need to use this part, right? What's that part? What's the shape, first of all? Cylinder, good. So I'm going to put it down there, cylinder. Are we finding the lateral area or the surface area of that cylinder? I think it's kind of halfway in between. We don't want the lid, do we? We do want the bottom. But I think it's easier to say, let's get the lateral area of that cylinder and then add on one base. Right? One circle area. And I like setting this up in this three component system. So then you can go about solving each component separately, keeping nice track of them, and then you can combine them. Okay, you have the rest of the period to work on this packet. Submit that, and you're done for the weekend, assuming you've done your circles test.